So for 11.3, we're going to talk about determinants. Determinants are basically a number that is associated with a matrix, a value that is associated with these matrices. So the book definition says if A, B, C, and D are four real numbers, the symbol D equals, now they use these kind of like straight up and down bars, look like absolute values. So it's not the little hooks that are on a regular matrix. This actually is a symbol that represents the determinant. This is called the determinant, and this is for a 2 by 2. There's also for 3 by 3 and 4 by 4. Determinants only, you can only find determinants of square matrices. So it has to be a 2 by 2, a 3 by 3, a 4 by 4, so on and so on and so on. So its value is the number AD minus BC. And again, this is for 2 by 2 matrix. That is to say that the determinant of ABCD is equal to AD minus BC. So you kind of just multiply it diagonally like this little cross right here that I have, this little X. So you multiply A times D and B times C and you subtract. And this is for 2 by 2 matrices only, okay? So let's just take a look at this real quick. So he says, find the determinant of the following. So all I'm going to do is I'm going to multiply A times D minus B times C. So this equals 2 times 3 minus negative 3 times 8. So we should get 6 plus 24, which is 30. So the determinant is 30, and we're done. Let's do the same for this one. Let's do this times this minus this times this. Negative 3 times 2 minus 6 times negative 5. So this will become what? Negative 6 plus 30. So this will become 24. So the determinant equals 24. Okay, and then we're done. And that's it. That's all you do for 2 by 2 matrices. Now, the thing is 3 by 3 matrices kind of step up a little bit. There's quite a bit more difficulty than that. It's kind of hard. Your book uses like a big, long explanation of it. So I just kind of want to show you. The main goal is that for 3 by 3 matrices, you have to memorize this pattern, okay? So you have to memorize plus, minus, plus, minus, plus, minus, plus, minus, plus, okay? So, and we'll come back to that in a second, okay? So here's the thing. The goal of a 3 by 3 matrix is to turn your matrix into a bunch of 2 by 2 matrices, okay? So what we're gonna do is we're gonna take, and we have this matrix in front of us, let A equal 4, 3, negative 5. So, 1, negative 4, 1, and then 1, 3, 4. This is a 3 by 3 matrix. So it is a square matrix. That means that we can do the determinant, or we can attempt to find it. By the way, determinants can be 0, but that is a special situation. When the determinant is 0, it means that the matrix does not have an inverse. We'll talk about that more in the next section. So basically, I don't want you guys to lose track. So in this section, what we're doing is we're finding ways to solve matrices. So right now, we're thinking of ways that we can solve a matrix. In the previous section, ways that we can solve a system of equations. In the previous section, we solved the system of equations using reduced row echelon form or row echelon form by using a matrix. Now, determinants are going to help us lead to another way that we can solve a system of equations. Determinants do more than just that, but that's one of the applications we're going to use. And remember, it's just a number that is associated with the matrix, okay? So we have our matrix A. So I want to find the determinant of A. So I'm going to put A right here, 4, 3, negative 5, 1, negative 4, 1, and 1, 3, 4. Remember, that means determinant. Let me write that better. Okay, so here's what we do. We build separate 2 by 2 matrices. So if we were in class together, I would show you that I'm covering up. So I can't really do that. So what I'm going to show you is I'm going to choose. Now you can choose any row or any column to be the column that you're going to work with. In general, if you don't have a better reason, just choose the first column, okay? So I'm going to choose the first column with the 4, with the 3, or not first column, the first row. I'm going to choose the first row with the 4, 3, and the negative 5, okay? So these are the coefficients I'm going to use. I'm going to use 4, I'm going to use 3, and I'm going to use -5. And I'm going to build another 2 by 2 determinant there, another 2 by 2 determinant there, and another 2 by 2 determinant there. Okay, so these are all going to be 2 by 2s because I know how to do 2 by 2s really well from this example up here, right? It's really nice and easy. So what we're going to do is we have to somehow work with this 4. So I'm right here on 4, and what I'm going to do is whatever row and column the 4 is in, we're going to wipe that column out. So I'm going to do this, I'm going to do this, and this is now my matrix that I'm going to worry about. -4, 1, 3, 4. Okay, now let me undo that. Oops, I can't undo it. I thought I had a genius way to do it, but it's not going to work. So now I'm going to undo those guys. Now for the 3, I'm going to do this column and this row because that's what the 3 is in. And that leaves me with 1, 1, 1, 4. So I'm going to go 1, 1, 1, 4. Okay. Hopefully you guys are able to follow along how I'm doing this. Now for the -5, this is where I'm at. So I'm going to wipe out his column and his row that he's in. And notice that leaves me this one right here. So I have 1, -4, 1, 3. Okay, so hopefully you guys see that. Now here's the thing. Here is where this matrix right here, or this pattern comes into play. If you choose the first row, you have to put a plus, minus, plus extra. Even if the problems come with their own signs, don't worry about that. You have to put that as extra. Well, plus signs don't change value, right? So this is just going to become 4 times the determinant. And then I'm going to do my little cross multiplying, this times this, right? Well, that would be 4 times -8 minus 3, right? Minus 3 times 4, and again, I'm just doing multiplying, 4 minus 1, minus, because a plus minus becomes minus, so -5, times, and I'm finding the determinant of this would be 3 minus a -4, so 3 plus 4. So this would become what? -11, so this would be -44. This would become -9, and then this would become, what is that? 7 minus 35. So when all is said and done, let's see here. Let me make sure I get the right answer for you guys. I got 4, 3, -5, so let's see here. When we add this up, that will be 11. Let me just add this real quick. -44 minus 9 minus 35. That doesn't seem right. Let's see here. Number 1C. No, let me see where I made my mistake. Did I write it wrong? 4, 3, -5, 1, -4, 1, 1, 3, 4. So let's do this again. Boom, boom. So -4, 1, 3. Oh, I see my mistake. You see this right here? This is not supposed to be a 2. This is supposed to be a 4. So I think the other ones are correct still. Oh, no, but I'll just do it again so I don't, butcher it. So, okay, so let's do this again. So this is going to be 4 times parentheses -16 minus 3 minus, now let's do this again. It's good practice anyway, right? So this one cancels that and that, and we're left with 1, 1, 1, 4. 1, 1, 1, 4, we're good. So this would be 3 times 4 minus 1 minus 5 times, now this would be, let's do this one now. The 5 would be gone and gone. And this would be 1, -4, 1, 3. Okay, we're good. So it was just that one that I wrote it wrong for some reason. I don't even know why. So this will be 3 plus 4. So now this will become -19 times 4. So I'm assuming that's 76, but I'm just going to do it on my calculator. -19 times 4. -76. That would be -9. And this would be -35. And we get -120. Okay, so that's not so bad. That's pretty good. So that's basically how you do a 3 by 3. You pick any column that you want, and you get the answer. Now, what if I chose a different column and a different row? Let's go from there. So I'm going to leave it as negative 120, and I'm going to just pick a new row. So let's say I pick this row right here, this guy, and this guy, just for fun. Let's say I pick that one. Okay. So what I'm going to do is I'm going to put my 1 here. I'm going to put my -4 here. I'm going to put my 1 here. Oops, let me move this over a little. Put my 1 here. And then I have to build another determinant of each of these 2 by 2s. Okay. So if I choose the 1, then that means I wipe this out and I wipe this out, and that becomes 3, -5, 3, 4. Okay. Now if I choose the -4, I close off this and I close off that. So I'm at 4, -5, 1, 4. And then if I choose the oops, I'm not there. I'm right here in this middle row. Remember, I'm doing this row this time. That means I close this off and I close this off, and I get 4, 3, 1, 3. Okay. Now I have to put the signs correctly, but I'm no longer working with the first row. I'm working with the middle row. And again, this is for a 3 by 3. So now I have to put a minus, I have to put a plus, and then I have to put an extra minus right there. So let's see what we get. Okay, so this would be, let me make sure that I didn't write anything wrong like last time. 3, -5, 3, 4. So this would be -1 times 12 minus or plus 15 plus, oops, minus 4 times 16 plus 5 minus 4, no, I'm sorry, 12 minus 3. So let's see what we get. We get -27, and then -4 times 21. So -4 times, I'm assuming it's 84, but I'm getting a little tired. I want to make sure that I don't make any mistakes. And then this would be what, -9. So -84 minus 9 minus 27. And I get -120 once again. So I just wanted to do it twice to show you it doesn't matter which row or which column you pick. You could do a column, you could do a row. As long as you incorporate these signs, you'll be okay. So these signs bring it in. And the goal of a 3 by 3 is to break it into 3 2 by 2s, right? So you can do the problem. So hopefully this helps you guys do them by hand. Now what I'd like you to do is, let me bring up my calculator. Let's program this into our calculator just to see if we can double check it on here. So now I'm going to take out my calculator. Oops. And I'm going to enter in the matrix. So I got to go second matrix. And I'm going to edit matrix A. And this is a 3 by 3, right? And it was 4, 3. What am I doing? 4, 3, -5, 1, -4, 1, and then 1, 3, 4. Okay, so I'm going to go second quit. I'm going to get out of here. And just like before, I'm going to go into math for matrices. I'm going to go second matrix over to math. And the very first one right there says determinant. So we're going to do the determinant of matrix A. So second matrix A, and hit enter. -120, just like we thought, right? So this is a way you can check your work. You have to know how to do them by hand, because sometimes what I'll do is I'll put a variable as one of the missing numbers. And the only way you could solve for that variable is if you know how to do it by hand. So doing it on your calculator is great, especially for Kramers rule. That's probably what I'll ask you to do, is use your calculator to help you set up Kramers rule. But when it comes to, you know, solving for a variable in the determinant, you're going to have to know how to do it by hand. Okay. So let's move on to Kramers rule. Kramers rule says, or Kramers rule is another method that can be used to solve a system of equations, and it uses determinants to find it. So remember in the previous section, we had to use a system of equations. We would turn it into a matrix, and then we would RREF it, and then we would solve, and that would give us our solutions. Or we could reduce row echelon form or row echelon form. Could, you know, in both methods we could solve. Now with Kramers rule, we're not going to do any of that. We're actually just going to find these numbers, like right here, how I have 120. I'm going to use determinants to solve without ever doing reduced row echelon form or row operations or anything like that. Okay. And kind of the method behind it is you have to find multiple determinants. And this is just for 2 by 2, but you could do it for a 3 by 3. So what I'm going to do is I'm first going to do it for an easier one. I'm going to do, let's solve using Kramers. And again, this is not, you know, if somebody asked me to solve something very quickly, I would just enter it in my calculator and do RREF. But I just want to show you an application of determinants. So solve using Kramers rule. And so realistically, if somebody asked you to solve, the main method you probably would want to use is not Kramers rule. But what if on the exam I ask you specifically to use Kramers rule? You have to know how to use it. Okay. So let's say that I gave you this system and I said x plus y is equal to 8. And then I told you x minus y is equal to 2. Now I can solve this problem way faster right now, just without using matrices, without using anything. I could get x equals 3, I bet, because I could just use the elimination method, cancel the y's. I'd get 2x is equal to 6, divide both sides by 2, x equals 3. Then I plug 3 in for x, and x minus y equals 2, so that means y is 1. And I'm done. I already know the solution. I can do it in my head. This is just practice. I chose an easy problem on purpose. I just want to show you how Kramers rule works. So first we take Kramers rule and we build our matrix 1, 1, 8, and 1, minus 1, 2. Put our little augment. So Kramers rule says that we need to find d sub x and d sub y for a 2 by 2. And when we divide them, and by the way, these stand for determinants. But it's a special kind of determinant. So if I'm trying to find capital D, what I do is I forget about the augmented portion and I just find the determinant of 1, 1, 1, negative 1. Okay, the part without the augment. And then I find this determinant would be negative 1 minus 1, which is negative 2. So we now know that D is worth negative 2. We have this now. Okay, now what we do, is we come over here and we have to find D sub x. So in order to find the determinant based on the x variable, what we do is we replace the x column in our matrix with the augmented portion. So this is going to become 8, 2, 1, negative 1. So notice what I did is I took this column and I put it right there. So that's where this column is now coming from, and it's where the x's used to be, right? So now when I find this determinant, I'm going to do negative 8 minus 2, which is negative 10. So I now have d sub x is worth negative 10. Okay, so I now have d sub x. But now I need to find d sub y. So in order to find d sub y, I'm going to do the same thing. I'm going to replace the y column with the augmented portion. So now I'm going to find the determinant of 1, 1, and then 8, 2, like this. And this will become 2 minus 8, which is negative 6. So d sub y is worth negative 6. So now here's the thing. In order to find x, all we have to do is, well, let me go back to the regular black marker. So now in order to find x, all we have to do is we take d sub x and divide it by capital D. So in this problem, d sub x is negative 10 and capital D is negative 2, so we get 5. If we want to find y, all we do is d sub y and divide it by d. But in this case, d sub y is negative 6 and d is negative 2, so we get 3. Okay, let's see here. Uh-oh. That's not what I said it would be. 5 and 3 is, or was I making that up for a different one? Oh no, I did say x would be 3. And then if I plug 3 in for x, when I did the one in my head for that, it was wrong. So the 3 was right, but then when I plugged in the x, I plugged it in for y, I believe, instead of plugging it in for x. So this turns out to be my solutions to the equation. So what I can do now is I can go on my calculator and I can just double check. I can do 1, 1, 8, 1, negative 1, 2. So I can go in here and I can go into second matrix. I can go into edit. I can change this matrix to a 2 by 3. I just want to see what the solution was. And this was 1, 1, 8, and 1, negative 1, 2, right? And I get out of here, and I'm just using the old-fashioned way. I'm going to use second matrix, and then I'm going to go all the way down to RREF, reduced row echelon form of matrix A, and I get X is equal to 5 and Y is equal to 3, the same as what Kramers rule told me. So again, both of these methods are doing the same thing. They're finding the solutions. I know X is 5, I know X is 3. So now, if we wanted, we could use Kramers rule on a 3 by 3. So let's do a 3 by 3. Let's say that we have the matrix 1, 1, negative 1, negative 6, 3, negative 1, 4, 5, and 1, 5, negative 3, negative 24, okay? And I want to solve for, let's say I only want to solve for Z. Instead of solving for all three of them to save time, let's just solve for Z, because if I can solve for Z, then I can solve for any of them, right? So Kramers rule lets you just solve for whichever variable you want. So what I'm going to do is I know in order to find Z, I need D sub Z over D. So let me find capital D first. And that would be 1, 1, negative 1, 3, negative 1, 4, 1, 5, negative 3. And now I'm just going to tell you guys right now for Kramers rule, I want you to use your calculator to find these determinants. Use calc to find determinants. Oops. Okay, so for these, for Kramers rule, I want you to use your calculators, otherwise you're going to run out of time. So for Kramers rule, I'm just going to take this and plug it in my calculator. Let me see here. So I'm going to go to second matrix. I'm going to edit, and this is a 3 by 3. And it is just 1, 1, negative 1, I believe. 1, 1, negative 1. And then 3, negative 1, 4. And then 1, 5, negative 3. Okay, hopefully I didn't enter any of those wrong. Now we're going to go into determinant, second matrix. Let's go to math, and let's go to determinant. And let's go second matrix, determinant of matrix A, hit enter, and we get negative 20. So now I get to go in here, and this equals negative 20. And this is from my calculator, right? Now I need to find D sub Y, D sub Z. But in order to find D sub Z, I have to replace the Z column with the augmented column, okay, or the equal sign column. So 1, 3, 1. 1, negative 1, 5, and now I'm going to do negative 6, 5. You know, I'll even write it in a different color so you guys know that I changed it. Negative 6, 5, negative 24. Okay, oops. So that is the augmented portion that replaced Z. Let's plug this in our calculator. I'm just going to do it on my one by hand because I'm faster at it. So I'm going to go second matrix, edit. This is a 3 by 3. And then this is 1, 1, negative 6, 3, negative 1, 5, 1, 5, negative 24. Okay, second matrix, determinant, second matrix. So I get negative 20. That's weird. Let's see, this is number 2C. Yep. So then I also get negative 20 for this determinant. And remember that Z is worth D sub Z divided by D, which is negative 20 over negative 20, which is 1. So Z equals 1, and we have our solution. Now we could go on to find X and Y as well, but they only asked us to find Z. On the exam, I might try to do this so you can save time. So you don't have to find all three X, Y, and Z, because that means you would also have to find the determinant of D sub X and the determinant of D sub Y. If I just ask you for one of the variables, you can use this and it's much quicker. Okay, so this is how you can use determinants to help you. Now, let me show you what a test question might look like also for solving determinants by hand. So let's say that I gave you x. Let's say that I gave you this x1, 1, 2, 3, 1, negative 1, 3, and 5. And I told you that this determinant was worth negative 5. So let's say that I told you this, okay? I want you to solve for x. So in order to solve for x, you have to know how to do this by hand. So what you're going to have to do is you're going to have to choose this. You're going to choose, I guess you could choose any row you want. I'm going to choose the first row, okay? So what I'm going to do is I'm going to say then that the determinant is x times sum 2 by 2, 1 times sum 2 by 2, and another 1 times sum 2 by 2. And then remember our formula or our pattern, plus minus plus for the first row, right? And then the next one, it's just alternating signs basically, you guys. So if it's not really a big deal, as long as you memorize plus minus plus, everything just alternates from that. So that means that this is plus minus plus. Whatever other signs come with the problem, that's fine. This has to be added though. Okay, so now we have, if we use this guy, we cross this out and we cross this out, and we have 3, 1, 3, 5. Okay, now we use this one, we cross this out and we cross this out. This will be 2, 1, negative 1, 5, right? This, and this, okay? Okay, now for this last one, we cross this out and we cross this out, and that leaves us with 2, 3, negative 1, oops, 2, 3, negative 1, 3. Okay, so now, let's see here. And we know that all this has to equal negative 5 because they told us the determinant was, so in this problem, we're not trying to find the determinant. They're already telling us this is determinant. They want to know what value it would have to be to make this happen. So now I'm going to do x times, this will be 15 minus 3, minus, and then this will be 10 plus 1, plus, and then this will be 6 plus 3 equals negative 5. So then this will be what, 12x minus 11 plus 9 equals negative 5. So 12x minus 2 equals negative 5. So then 12x equals 3, negative 3. So then divide both sides by 12, divide by 12. So x equals negative 1 over 4. Let me see if that's right. That doesn't sound very nice, but let's see. Number 3b. Yeah, it's actually negative 1/4. So that means if we take this number, negative 1/4, and we plug it, oops, we plug it in right there. If we plugged it in for x and then we did the determinant on our calculator, we would get negative 5, okay? So this is how you can use determinants to solve for variables inside the determinant. It's something that you want to kind of, you know, this is how I can test you and make sure you know how to do it by hand and not just on your calculator. You should know how to do it on your calculator, especially for Kramers rule. And I need to see like this. I need you to show me that you found D sub Z, and I need to show me that you know how to find D. But then, you know, just write this one little step and then you're done from there. That's pretty much how you'll show your work for me on the exam. If you just show me the answer without any of this, I'm assuming that you just did RREF on your calculator, and I'm not going to give you credit because it'll say use Kramers rule. Okay. Let me see. That's it. There's some things I want to talk to you about actually for determinants. Let me see. There's a few facts that we can talk about. So your book calls them theorems. So I'll call them theorems, but I didn't learn them as theorems. I learned them as properties, but so let's talk about these theorems. Okay, so it says the value of a determinant changes sign if any two rows or columns are interchanged. Okay, another theorem. So this is one of them. Here, let me write this next one. So if all the values in a row are 0, the determinant equals 0. Okay, so if all the entries in any row equal 0, then the value of the determinant is 0. Okay, so that's basically saying that when we had one of those matrices that we did and we ended up, after doing RREF or reduced row echelon form or row echelon form, we ended up with a row of zeros. That means that the determinant will end up being 0 as well. Okay, let's see here. If any two rows that's not the one I wanted. If any row of a determinant is multiplied by a non-zero constant, multiplied by a non-zero constant, k, or number k, I guess, non-zero number k, the value of the determinant is also changed by a factor of k. Okay. Now, here's the last one. So I don't want to write all this out, but so you know how there were the row operations where you could interchange any two rows? That one is this one right here. The value of the determinant changes sign if any two rows are interchanged. So what that says is that it just changes the sign of the determinant. Okay. This one says that if you multiply a row by a number k, then the value of the determinant is changed by a factor of k. Okay, so that's another one of the row operations. Now, the third row operation says that if you add a row, or if you have a row and you add a multiple of another row to it, that's the third row operation. Well, that one turns out to do nothing. That one actually does nothing to the determinant. So by doing that, the value of the determinant remains unchanged. So even though it's the most complicated of the row operations, it actually does nothing to the determinant. Okay, so that's definitely something that you want to keep in mind. So let me see if I have one for you like that. So here's a problem. So they might give you one like this. So they might say, here's the determinant. Oops. Based on one of these, it says, find the value of x, y, z, negative 4, 5, 4, u, v, w, if you know that this determinant, negative 4, 5, 4, x, y, z, u, v, w equals 6. So if you know that that determinant is 6, well, what would it do to the determinant in order to rearrange it? So let's see. We have this guy worth 6, okay? They basically took this row and moved it right there, right? And then they put XYZ up top, okay? So what row operation that is we interchanged two rows. So if we come up here and we look, it says the value of the determinant changes sign if any two rows are interchanged. So then I know that this is worth -6, and that's it. That's all there is to it. So that's what those theorems are telling you, is that that's a relationship. By doing row operations on the determinants, that's the relationship that would happen. Remember, row operations say things are row equivalent. It does not say they're equal. So there's a difference between row equivalency and equality, okay? And that's why when I'm taking one, when I do one matrix, I use arrows. I don't actually say equals, because that would be a lie. It's not exactly the same. Okay, so that's just something to keep in mind. I don't want to spend too much time on that. That's starting to get a little bit more complex. We're trying to intro you to linear algebra and into matrices. So remember, if you go on to Math 254, or some schools, I forget what the numbering is, but this is basically linear algebra. This is like an intro. This will help you a little bit when you take that class. Okay, and to be honest with you, matrices come up a lot in Calc 2, not as much in Calc 1, and I don't want to say a lot in Calc 2, but in Calc 3 they should also come up as well. I've even had some students say they use matrices in chemistry to work with chemical reactions to see what the leftovers are. And there's a lot of applications of matrices because it's solving systems of equations, and systems of equations are used to solve many problems, okay? So that's going to do it for this video, you guys. Thanks for watching.